My friends, welcome to this presentation. My name is Miroslav, and I will talk about the research that I did together with my colleagues on using machine learning to identify code fragments for manual review. We work usually with a continuous integration, and the typical path for the review of a patch in a CI or a workflow looks like this. We have the original code base that software designers check out, clone, and make changes in the code fragment. Then they submit this code fragment for review, which triggers Gerrit's review workflow, static analysis, and tests. Then it triggers also the reviews or the difference between two versions of the code, which in turn triggers the reviews that are manual. So emails are sent out to the reviewers who read and comment on the code. In the end, they have to agree whether the code is good enough to be submitted or integrated with the main code branch. And if it's good enough, it's integrated. The scope of our work is those three activities. The focus of the reviewers on the important code path. The problem formulation is that we have observed that there is a lot of code that's being committed to main branches. In modern software companies, we're talking about a number of different commits per day, could be even tens of commits, and a significant number of lines of code, depending on the company, on the number of team members, number of teams. The challenges, however, are that it requires a lot of effort to review them, and quite often it's difficult for the reviewers to find the right focus. If you get 1,000 lines of code to be reviewed, which is not uncommon, how do you find the line that is important? And especially if the lines or code fragments are distributed over several different files. So the challenge that we address is how to automatically identify those code fragments who should be reviewed manually to give a proposal to the software reviewers. Our approach is to use Gerrit and machine learning, where we take historical data from Gerrit, and then we export that. We create feature vectors based on the lines of code itself and the sentiment analysis on the comments. Then we train the machine learning classified based on the on tools that are available in the standard libraries, for example, ADA boosts or neural networks. And then we apply those trains classified on new code patches and identify lines of code and code fragments that require manual review. To illustrate how it works, let me go back to the original example of this small function that swaps two numbers. It is a function that has been commented by one reviewer, that particular line number 5, which says that the temp variable should not be used over here. It should be something more informative. What we do is we export that data from Gerrit into a pair where we have a line and a comment. Then we separate lines and comments and extract features from the lines. For example, which keywords are used, which specific tokens like temp, whether there is an assignment operator, whether there are brackets inside. We also take the other part, which is the comment, and we conduct a sentiment analysis. In our approach, we do it quite rudimentary in a simplistic way by counting positive and negative words in the reviews. And then we put together them in the end, creating a large matrix, which we use for machine learning classifiers, which contains on one side the features extracted from the source code and the class to be predicted later on that we train the classifier with, which is the sentiment. We evaluated our approach by applying that on 4 different cases. We used 2 companies that have a large number of code developed professionally. They both work in Agile or even post-Agile world, and they use different programming languages. We also evaluated that on 2 projects from open source, Wireshark and GRUMACS. Both projects are open source, but also backed up by professional organizations. Wireshark is a communication protocol used in many applications, so there is a lot of professionals from telecommunication companies supporting that. And GRUMACS is scientific software, which has been used quite a lot. Our evaluations show that when we link together neural networks with sentiment analysis and we manually select the number of the features that we could use, so we are a bit smarter than the statistics, we could achieve the F-score, which is quite hard, and MCC score, which is even better measure of accuracy than the F-score, of about 0.7 on a scale from -1 to 1.0. However, we also discovered a number of challenges. One of the challenges is the data collection itself. In this example, we extract the information about the lines of code that are commented, but how about the lines that are not commented? Should they be ignored, which we do today, or should we use those lines of code and treat them as code that basically is good enough? We also have challenges with lines annotation. Now, in this particular example, I showed the line that has been commented specifically. So there is a comment linked to a line. However, sometimes the reviewers actually comment the entire fragments, which means that the same line of code could be in fragments that are commented positively and negatively. And that poses a challenge of noise in the data. We also think about cases when we don't really know what's the sentiment. I mean, in our approach, we use a simplistic approach, but there are other things, and this language is not that's used in the review is not really the same kind of language that you use in books. So it's a specific kind of language. So the sentiment analysis need to be aligned a bit more. And also, how do we present the results that we're not certain of? Right now in the AdaBoost scenario, we have the algorithm that is binary, gives an example of a line that is positive, okay or not okay. But the neural networks, they provide the example in continuous spectrum. So we could actually provide some sort of uncertainty to our decision and test of that. And in our next steps, we try to evaluate all that. We also try to understand what is written in the code and commented in the code, so we can give a recommendation to a reviewer about what is potentially wrong with that particular code fragment, not only that he or she should focus on it, but also what he or she should focus on, and also extracting rules from the comments that can be used as coding guidelines for younger developers and helping knowledge transfer in modern companies. And to conclude our presentation, I think the results are very promising. We have the MCC that is quite high. We use this approach to reduce the burden of code reviewers. And in our further work, we are planning a back-to-back evaluation with the companies. And also we want to understand how the design choices impact our results. For example, ignoring the lines of code that are not commented. What happens if we actually include those lines of code as positive lines of code? What happens to the algorithm? How to reduce the noise over there. So thank you very much for listening, and I hope that you will find time to also visit our website, www.softwarecenter.se. Thank you.